ABC. This is your triangle ABC. Here PQ is a line segment intersecting AB at P. This is P and this is Q at AB and AC. And this PQ is given as parallel to BC. It divides ABC into two equal parts, equal area. That is, this area and this area are equal. So you can say area of APQ, that is this triangle, above triangle, and this trapezium, or you can say it is actually a trapezium, but we'll call it as a quadrilateral right now. So these two are equal. Now what we can do here is we can add area of this above triangle to both the sides. So when we add this on both the sides, that is this one and this one we added, what do we get? This is twice of area of triangle APQ, and this will be area of quadrilateral, that is, and this is APQ. So this is APQ, and this one is quadrilateral BPQC. So this is BPQC. Now when we add this, it is actually ABC, triangle of ABC, triangle ABC. So this is area of triangle ABC. So area of triangle ABC. Now since these two triangles, we can make it as look similar. How? First of all, since this is parallel, so this angle will be equal to this angle, corresponding angle. This angle equal to this angle, corresponding angle. This angle is common to the triangle APQ, that is above triangle, and the main triangle. So the main triangle, which is this one, is similar to this triangle. Now we know that when we have similarity of these two triangles or any two triangles, so area of the two triangles ratio will be equal to the corresponding side square, that is area of APQ by area of ABC. We can write it as AP by AB, that is we are taking this side, AP by AB, right? So now here this area of triangle ABC, see what we have done already is the twice of area of triangle APQ is equal to area of ABC. So when we say area of ABC or APQ, we can write twice this area of triangle ABC as this twice, is not this, twice of area triangle APQ. This gets cancelled, so this is 1 by 2. So AP by AB whole square is 1 by 2. What do you get? AP by AB equal to 1 by 2. This is what you get. This is square. So AP by AB is equal to 1 by root 2. We have taken square here, right? Now one more thing here is, what is this AB? AB equal to AP. AB is AP plus PB. AB equal to AB is AP plus PB, right? So in the place of AP, you can write AB minus PB, AB minus PB. So in this place, AP will write AB minus PB or BP. So this is AB minus PB or BP by AB equal to 1 by root 2. So what do you get here? Let us divide them. So AB by AB will be equal to PB by or BP by AB minus equal to 1 by root 2. This is 1. So 1 minus BP by AB equal to 1 by root 2. So take this on the right hand side, bring it here. 1 minus 1 by root 2 will be equal to BP by AB. So what do you get? BP by AB will be equal to, this is root 2 minus 1 by root 2. So root 2 minus 1 by root 2. This is the BP by AB. Next is the area of two similar triangles. These two are in the ratio 9 by 16. If one side is given, second side has to be found out, and this we have already done. So this is when the two triangles are similar. So we say area of ABC by area of PQR is BC by QR. We are taking the corresponding side square. This is 9 by 16 as given the question. BC is 4.5. So you can take square as root here. So this will be 3, this will be 4, and ultimately QR can be found out by 4 into 4.5 by 3. So this will be 6 centimeter. Next is ABC is a triangle and PQ is a straight line meeting AB at P and AC at Q. So this is the scenario. These sides are also given. AP is 1, PB is 3, AQ is also given 1.5 and QC is also given 4.5. You have to prove that the area of APQ is 1/16. That is, area of this triangle is 1/16 of the main triangle ABC. So first of all, let us see that whether this line is parallel to this line or not. If this is parallel, then we can take the ratio of these two sides and try to find out whether this line is parallel or not. So this is 1, this is 3. So 1 by 3, because this P is dividing AB and Q is dividing AC. So this line will be parallel to the base when the ratio of this side will be equal to ratio of this side. Let us see, 1.5 by 4.5, and this is 3 only. So now when the ratios are similar or equal, that is, this line is parallel to BC. When this is parallel, this angle will be equal to this angle will be equal to this angle, and this is common. So the above triangle, that is APQ, is similar to the main triangle ABC. Now when these are similar, so we can take the ratio of the area. So area of APQ, that is the smaller triangle, and area of ABC, which is the larger triangle, will be equal to, this is AP by AB whole square, right? Now AP and AB, what is AB? What is AB? AB is AP plus PB. AP plus PB. This whole line is AP plus PB. What is AP? It is 1 given in the question. This is 1 and this is 3. So 1 plus 3, that is 1 by 4. So let us put 1 by 4 here, 1 here, 4 here. So 1 by 4 is, and we have to take square also. So 1 by 4 square is 1 by 16. So now the ratio is 1 by 16, which is area of APQ is 1/16 that of area of ABC. If you take ABC here, it will be what is sought in the answer. If D is a point on the side AB of triangle ABC such that the ratio is given. So the ratio of AD by DB is given. So AD by DB ratio is given as 3 by 2. So if AD is 3x, DB will be 2x, right? Now when these two triangles, means the upper triangle, which is BDE, this triangle, and the main triangle ABC, which is this one, and it is given that D is parallel to AC, it is given in the question. So we have to find the ratio of the main triangle and the smaller triangle, that is the above triangle. So we know that because these two are similar, why? See, this is parallel. This angle will be equal to this angle will be equal to this angle, and this is common to both the triangles. So triangle BDE is similar to triangle ACB. Now we can take the ratio of the area. So area of triangle ABC by area of triangle BD will be AB by BD whole square. But AB is what? AB is AD plus DB. AD plus this AB is AD plus this AD, and this is DB, right? And of course we have DB here. So as we said that if AD is 3x, if this is 3x, what is DB? DB will be 2x because the ratio is given. DB is 2x. What do you get? 3x plus 2x is 5x, and this is 2x. X gets cancelled, 5 by 2 you get. But this is square. See, this is square, so you have to take square. 5 5 is 25, 25 by 4. So area of ABC by BD will be equal to 25 by 4. If triangle ABC and BD are equilateral triangle, D is the midpoint of BC, find the ratio of areas of ABC and BD. Now these two are triangles. The formation is like this. This is one triangle, this is one triangle. And these two triangles are equilateral. Equilateral, all the triangle in the world which are equilateral, they are similar. So you don't have to worry about this, because any triangle you take equilateral, 60, 60, 60. These are angles. So of course, by AAA, these two triangles are similar. These two triangles are similar. When they are similar, then we can take the ratio of the side. We can take the ratio of the side, that is, and since this D is the midpoint, so if you take this whole BC as 2x, then BD will be equal to x, and DC will also be equal to x. This will be also x. Now take the ratio. Area of triangle bigger one, ABC, by area of triangle this one, that is BDE, will be equal to BC, this whole from here to here, by this BD. So since this is, we have taken as this as 2x, this will be x, and this is square. This is square. X gets cancelled. 2 square is 4, so this will be 4 by 1, that is 4 is to 1. This is the ratio of the area of the triangle. Two isosceles triangle, they have equal vertical angles and their areas are in the ratio 36:25. Find the ratio of their corresponding heights. As we said, the corresponding height, that is altitude, that is h1 by h2 square, will be equal to area of first one by area of second one. So we directly do this because we have discussed this already. So area of first one, area of second one, that is 36 by 25, will be equal to height of the first one, which is given as the we have to find the ratio of the corresponding height. So this is say h1 by h2, this square, take root here, eliminating square, we have taken root, so this is 6 by 5. So height 1 by height 2, that is this AD by PS, is equal to 6 by 5, that is 6 to 5. 6:5 is the ratio of the corresponding heights. Next is in this, let me show you the figure. In this figure, ABC, that is this ABC, and this triangle, the above triangle and below triangle, that is B, or you can say DBC. These two triangles on the same base, which is this BC. This is on the same base. So if AD and BC, they intersect at O. So they are intersecting at O. You have to prove that the area of triangle ABC, the above one, and the area of triangle which is the below one, is AO by OD. So what we will do here is, first we will draw perpendicular. So this is AL, we are dropping perpendicular AL for this triangle ABC on base BC. Now for this triangle BDC, we are dropping a perpendicular this DM on this BC. Now you see, when these two, we have to take these two triangles now. This smaller one, this smaller one. Here these two angles are vertically opposite angle. This is 90 degree, this is 90 degree, because by construction we have dropped the perpendicular. So by AA similarity criterion, this triangle smaller one is equal to, or this similar to, sorry, this triangle is similar to this triangle. So what we can do here is, we can take the ratio, that is AL by DM will be equal to AO by DO. This DO, you can always do that. This has come because of the similarity criterion. Now what is the area of triangle above triangle? If I take this triangle, which is A, B and C, and this is the perpendicular we drop, AL. So what is the area of the triangle? Half into base into altitude. Base is BC, into altitude is AL. Similarly for this triangle, base is already BC, half into BC. Now here the perpendicular is DM. Let us write DM. So what is the ratio? It is only AL by DB. AL by DM, sorry. AL by DM. So AL by DM, this gets cancelled, this gets cancelled, AL by DM. But we already proved that AL by DM is AO by DO. So we can replace AL by DM by AO by DO. And this is what we have to prove. Next is ABCD is a trapezium with AB parallel to CD. So this line is parallel to this line. This is a trapezium. The diagonal AC, which is this one, this A and C, this is the diagonal, and this diagonal BD, the diagonal is BD. It has to be BD. It intersects at O, right? Now we have to prove first of all that these two triangles, which is AOB, this triangle and this triangle, they are similar. How to prove that similar? That is, first of all, this angle is equal to this angle, which is vertically opposite angle. Okay. And then second thing is that because these two lines are parallel, AB is parallel to DC. So we have two lines like this. This angle will be equal to this angle will be equal to this angle. Why? Because these are alternate angles. So by AA criterion, this above triangle is similar to this triangle. First thing is this, we have proved this. Now we have to find out the area of AOB by COD. This is just a repetition. So AOB by COD, area of triangle AOB. So area of triangle AOB, we know that area of triangle AOB by area of triangle which is below one COD will be equal to what? See, we are taking the corresponding side because these two are similar. So AO, we are taking above one, AO by OC whole square. So AO by OC whole square, we are taking the corresponding side. But the question, it is given AO as 6 and OC as 8 square. So this is 2 3s are 6, 2 4s are 8. So this is 3 by 4 whole square, which is 9 by 16. So the ratio is 9 by 16. This is what the answer is. So this is 9 by 16. Okay. Every time this is there, you need to simplify it also. That is why I have written as 9 by 16. The next question is, in a triangle ABC, P divides the side AB such that AB is to PB is 1:2. So now AB, that is this whole, is to PB is 1:2. That means P divides AB in 1:2. So AP is to PB is 1:2. AP is to PB. So let me write this first. AP by PB equal to 1:2. So if we take AP as X, PB will be equal to 2X, right? Now it is also given that this PQ is parallel to BC. When these two are parallel, that means we can take this triangle, and this triangle means this APQ and the main triangle ABC. So we can take the ratio of these two, and we know that these two are parallel, these two are similar. How? This angle is common between APQ and ABC. This angle is equal to this angle equal to this angle. By A similarity criterion, triangle APQ is similar to triangle ABC. So we can say area of triangle APQ by area of triangle ABC will be equal to AP. Let us take this side, AP by AB whole square. Now as I said, if we take AP as X, so I am taking AP as X, but AB is what? AB is nothing but AP plus PB, AP plus PB. But AP, if we take as X, PB will be 2X. Okay, so we can write 1X plus 2X in place of AB, but this is 1X plus 2X is 3X, and this is square. X gets cancelled. This will be equal to 1 by 3 whole square, which is equal to 1 by 9. So now the area of APQ by area of triangle ABC is 1 by 9. Now see, first of all, we have to find out the area of APQ. APQ, area of triangle APQ by trapezium BPQC. Area of triangle trapezium BPQC is what? Area of triangle ABC minus area of APQ. Okay. Now if we take area of this is 1:9. So if we take area of APQ as X, that is I am taking it as X, what is the area of triangle ABC? It will be 9X. So this will be 9X. So 9X minus X is 8X. Okay. Now when we take the ratio of triangle APQ we have taken as X. So X, and area of triangle BCD we have taken as 8X. So we take the ratio. What will be this? X gets cancelled. It will be 1 by 8. So these were the question and answer of this topic. Thank you so much. Take care of yourself.